And simplicity is based on how you understand the program. Okay. I hope I'm audible to you all. Yes, students?
Yes, mommy, audible.
Yeah. So the program number of today's class that we'll be discussing is about lab program 5B. Okay. The agenda of today's session is to know about what is Tower of Hanoi problem. First introduction to it. The reason because we are writing a program to provide solution for Tower of Hanoi problem. Okay, and how exactly this Tower of Hanoi problem is being solved recursively. So you all know that any problem can be solved in two ways. What are the two ways of solving any problem, students? Can anybody reply? Okay. Say I give you find factorial of a number. So there are two ways to solve that particular problem. Can anybody tell me? What are the two ways? Two programming paradigms or two ways of solving factorial of a number which you would have seen in your theory class, students.
Ma'am, one using for loop, other using recursion.
Okay, so the one using the for loop, right? You put a for loop something like for I equals to 1, I less than equal to n, I plus plus, fact is equal to fact star I, where fact is initialized to 0. So the other way around also you would have written the for loop. And such way of solving solution to the problem, we call it as iterative solution. Iterative. You are iterating over something to find a solution to the problem. And the second way of solving is recursive solution. So, our Tower of Hanoi problem, which we are discussing today, can be solved in both the ways. But recursive will reduce the number of code which is required for me to do, isn't it? And it is a faster way of finding solution to a problem. That's also one of the advantage. So we will see that. So as a part of solution, we are seeing recursive here. We're not saying iterative because it's quite lengthy for us to solve. So recursive is quite simple and small to find a solution to the problem. Then followed with that, we have a program and then the demo. Okay. And before I tell you the introduction part, I'll just tell you the aim of the program here. The aim of the program is quite very simple. You have to write or implement a program, design, develop, and implement a program in C for solving Tower of Hanoi problem with NDES. Okay, so it is lab program 5B. So you have also have 5A, which we have not covered. 5B is this problem. So in the exam, you have to write both A and B. So it is a single question. Question number 5 has two problems or two programs. One is 5A and 5B. The 5B goes like this. Okay. So to move on with, anybody knows what is this Tower of Hanoi problem? Anybody knows? I think most of you would have played this game. Any idea, students? Any idea? What is this Tower of Hanoi problem? Any idea? Students, speak out. Yes or no? Tower of Hanoi problem.
Ma'am, it's a game where we get to arrange discs in terms of their sizes.
Okay. Then, anything else? That's all?
Yes, ma'am, we have to arrange it in such a way that the larger disc does not fall upon the smaller disc.
Okay. You have only discs there. Apart from disc, do you have anything else?
No, ma'am.
No? Okay. Well, I'll just play one video for you all. Just tell me whether it is audible so that I'll continue playing it. Is it audible for you all? It's reply.
To show the application of
Is it audible,
recursion, there is
students?
nothing better than the power of HANOI.
Yes, ma'am.
Okay, just a
Power of
second.
HANOI is very
Just to show how exactly what is tower of HANOI problem, I have just playing this video. Just try to concentrate on it. Okay, then later I'll ask you some questions. Then we will go for the recursive solution. Okay.
To show the application of recursion, there is nothing better than the puzzle Tower of HANOI.
One
Tower of HANOI is
second.
a very interesting puzzle, and many of you may already know about it.
One second, students. I'll just mute myself. If I mute, they can hear my. Students, if you find any problem with listening to the audio and video, kindly reply. Okay, you can do that. Okay.
To show the application of recursion, there is nothing better than the puzzle Tower of HANOI. Tower of HANOI is a very interesting puzzle, and many of you may already know about it. So there is a story that there's a place called Hanoi, I think in Vietnam, where there are three towers and with about 100 discs. And the monks there have to move all the discs from one tower to another tower by using certain rules. And it is said that by the time all the discs are moved from one tower to the other, the world will end. But the world has already ended many times now, and it's probably become quite boring to even talk about it. But anyways, so let's go over the rules of the puzzle. Okay. Now here we have three towers A, B and C, and we have some discs in tower A, which are arranged in the increasing order of size from top to bottom. And what we are supposed to do is to move all the discs from tower A to tower C using tower B as an intermediate, such that at no point of time a bigger disk comes on top of a smaller one, alright? And one more rule is that we can only move one disk at a time, alright? So let's look at a few examples to make the idea clear. So let's say we just have one disk. So this is simple. We can just move disk 1 from the tower A to tower C directly and we are done. By the way, we have named the towers and numbered the disks so that we can track the movement. And in our program, when we write one, we will be printing out these messages. Alright. So if there are two disks, we number them as 1 and 2, 1 being on top of 2. Alright. And this order of numbering the disk is important for our algorithm. So in general, we'll start numbering the topmost disk as 1, which would also happen to be the disk with the smallest radius, and then keep increasing the numbers as we go down the stack of disks. And in this case of two disks is also quite simple. We first move disk 1 from tower A to B. Then what do? Move disk 2 from tower A to C, right? And finally move disk 1 from tower B to C, alright? And this was also quite simple and something which everyone can figure out. Then what about if we have three disks? And you will notice that by adding more disks, the complexity of the problem increases, and slowly with few more disks, it will become much harder to write all the steps correctly. Anyways, so before moving on, you may want to pause the video here and write the steps yourself. This one is also quite easy. So what we can do is that we move disk 1 to tower C from tower A, then move disk 2 from A to B, move disk 1 from C to B, move disk 3 from A to C, and now we would like to move both these disks 1 and 2 to tower C. But because we can only move one disk at a time and without keeping the bigger disk on top of the smaller one at any point of time, we first need to move disk 1 from tower B to tower A and then move disk 2 from tower B to C, and then finally move disk 1 from A to C. Alright? And this was a little more intense than the first two cases. And as the number of disks increase, identifying the steps become increasingly complex. And actually it is so complex that it will really be hard to write a program which moves these disks iteratively. And this is where recursion comes to help and makes this problem quite easy to program. All you have to do is to focus a little and align your thoughts along the lines of recursion. So let's say we write a method move which takes 4 parameters. The first one is the number of disks that need to be moved. And then the other 3 parameters can be of char or string types representing the towers. So the first one out of these 3 is tower from. So we passed A here. The second is tower to. That is, the disks are to be moved from tower A to tower C. And the third parameter is the intermediate tower, where we pass B as argument. So when we call the move method with these parameters, we mean that move n disks from tower A to tower C using tower B as the intermediate. And first you should convince yourself that this is possible. That is, we can move all these disks from A to C using another tower. And if you are convinced, let's proceed. So if we can do that, it essentially means that we should be able to move these n-1 disks from tower A to tower B using C as an intermediate, right? Think about it. Because the nth disk is the largest in radius, it can remain untouched when we are moving those other n-1 disks like that, right? So we should be able to move these n-1 disks from A to B using C, which means that we can call the move method for n-1 disks from A to B using C, isn't it? Notice that the order of arguments for from tower to tower and using tower has changed, alright? Then we can move disk n from A to C, which is what we can print. And then we recursively move these n-1 disks from tower B to tower C using tower A. So we can again call the move method recursively with this different set of parameters. And this whole recursive approach just needs to be synced in a little. And to help with that, let's revisit that 3-disk example again. So here what we are saying is that we want to move 3 disks from tower A to C using tower B, which means that we can move 2 disks from tower A to B using C. And what we did earlier was that we first moved disk 1 from A to C, then we moved disk 2 from A to B, and then moved disk 1 from C to B. So essentially the state of the system right now is exactly as if we moved the 2 disks from tower A to B using tower C, right? Which was done recursively. And we don't really care about the details. So we are done with this part. Now we move disk 3 from A to C. And finally we move these 2 disks from B to C using tower A. And if we see the details, that is what we end up doing, right? So as you can see, thinking recursively makes this problem much easier to solve, but of course it needs a little practice and patience to be able to align your mind in that direction. And of course, we need to put a breaking condition. But let's implement this program and we will talk about the breaking condition there. Before moving on to the next lecture, I suggest that you try implementing the program yourself first.
Okay. Yes, students. What is tower of HANOI problem now after watching the video? What is tower of HANOI problem? Students. Students, are you all there? Am I audible? Am I audible?
Yes, ma'am.
Okay. So what is tower of HANOI problem? What are the inputs for the problem? Look at I think the diagram is visible, the picture.
Yes, ma'am.
Okay, so what does it mean? What does it, what do you tell? What are the inputs to the problem? We have how many pillars? How many?
Three.
We have three towers, okay? So the terminologies will be like three towers or three peg, PG, okay? We call it as PG, peg, okay? And we have three pegs or three towers, okay? And three towers are named as it is, like first one is your source tower, source peg, and B is your temporary peg or auxiliary peg. C is your destination peg. Okay. And on the source peg, we have what, students? We have what? Quickly. On the source peg,
Discs.
disk. So we can have any number of disks. So n disks. Okay. And what should I do? What is the task of this problem? I have to move all the end disks from where to where? From where to where? Speak out.
A to
Close
C.
to the
Source to the destination. Okay? In the same order, I should place it. You can observe here the disk, how they are placed. They are placed in the decreasing size, right? Decreasing. You can see the bottom one is the larger one. Okay? And it goes on. Okay? Decreasing in the size. So your disk can be of any shape. Yeah. Here you can find it is a rectangular shape. It can be a triangle shape. It can be a circle, anything. Any disk of any shape can be placed. So the motto here is to move A to C using B. Okay. With some conditions. Can anybody tell what are the conditions? What are the conditions if I have to move? Can I move it in any fashion? Place it on C? How many disks can I move at a time, students?
Only one disk, ma'am.
Only one disk I'll have to move at a time. First condition. And the second condition here is, the second condition is what? You cannot place what on what?
Bigger one on the smaller one.
Bigger one on the smaller one. Yes, very good. That's the second condition. And the third condition is you don't have any, what do you tell? You don't have n number of auxiliary pegs. So you have only one auxiliary peg. Your problem would have been easier if there was two auxiliary pegs. Yes or no? But you have only one auxiliary peg. Using that, you should do this transfer. Very simple as it is. So as you can see now, we have seen to move one disk. How many movements I should make? One disk is there. How many movements will happen, students? One disk. One disk means
Only one.
only one, isn't it? You can see the example here. Okay, one disk is there. I'll move the disk from A to
C.
where? See, one move. For one disk, we have one move. Very simple as it is. I'm not using auxiliary peg. Not required. Okay. Suppose if we have two disks. Okay. So for my to design my program, I will name the disks in the order of top to bottom, 1, 2. So if there are 2 disks, how many moves will I make? How many moves? How many?
3.
How many moves?
3.
3. What are the 3 moves? Can anybody tell me? First move you tell. Someone can tell me the first move. Move what to what?
B.
A to B.
1 from
Move,
source to
move the disk. How many disks can I move at a time?
1.
One, and which is at the topmost. That's understood. In between, you cannot take a disc and move. That's not possible because it is like a peg. You place it on it. I think you can see that the toy which usually kids will use. I think that pyramid kind color rings are there to teach colors we take for kids. Similar wise this is. So first movement, move what to what? Move disc 1 from where to where? From where to where? Move disc 1 from where to where, students?
A to B.
A to B.
B. Move disc 1 from A to B. Then next movement. Next movement. Move. Next movement.
2 from A to C.
2 from A to C. Very simple. 2 movements. Next, the third movement. Move what to what?
B to C.
1 from B to C.
1 from B to C. So totally for 2 discs, I had how many moves? How many for 2 discs?
3, ma'am.
Moves. Similarly, as the number of moves increases, okay, the complexity also increases. Now let us see when it is 3 discs. So very simple. When there's 3 discs, what should I do is, I should move the discs, that is top n minus 1 disc, that is disc 1 and 2 to B using C. Okay, top n minus 1 disc. So what should I do? How do I move this, students? Move
Move 1 from A to C.
C, move 1 from A to C. 1 second. Move 1 from, where is it? A to C. 1 move, just count. Then next movement. Move
2 from A to B.
this 2 to B, A to B. Sorry, A to B. I'll move. The second movement is like this. Next, third movement is move disc 1 from C to B. Can you observe this? So, I just moved the top n minus 1 disc from A to B using which peg? Using which peg? Using which peg? Which peg did I use to move 1 to 2? 1 and
7.
C.
Source to
Source to, I just moved it to auxiliary using the destination. Remember. Okay. So how many moves I had? I moved 1 to C, then 2 to B, then from 1, that is which is on C to B. So I had totally 3 moves. 3 moves. Then the next one. Next one. Next move is what?
3 from A to C.
There's only 1 disk now. See, when I have moved n minus 1 disk, there's only nth disk available. So move 3 from where to where, students? A to
C.
C.
directly. Then the next movement is what? I should move from B to C using which peg? Move B to C using which peg?
Source peg.
Source peg. So what is the movement again now? Move
1 from B to A.
1 from
A
A.
to A. Yes, very simple. 1 from B to A. Then 2 from next move. Next movement. In this
From B to C.
from
B to C.
B to C. Okay, I have one question. Can I move 1 from A to C? Is it possible? Can I move 1 from A to C? Then place 2 on that.
No.
No, as per the rule, it is not allowed. See, though you move 1 from A to C, again you'll have to take it out. There's no point in moving, isn't it? Right? So you can say now, moved this, then finally move which to which? 1 from?
A to C.
So totally I had 3 moves. So in general, the diagram is like this. You can see you have n disc. So I'll have to move n minus 1 disc from where to where? Move n minus 1 disc from where to where? A to students. I will divide the problem into 3 phases now. First, what I should do is, I should move n minus 1 disc, which is on the source peg, to which peg? To which peg should I move n minus 1 disc?
B, ma'am.
From A to B. What is the name given for B?
Auxiliary.
Auxiliary. Very simple. So move n minus 1 pegs from A to B using which peg? I cannot move directly. See, I moved it here directly. I cannot do that. But using which peg can I do that?
Destiny peg.
Using the destiny C. Yes. Using C as my peg. So I will just do. That is the first part of your recursion. Right? Moving n minus 1 disc. Can you see that? Move n minus 1 disc from A to B. So you should understand here, A is my source, B is my auxiliary, C is my destination. But here, moving n minus 1 disc will be from source to the auxiliary using the destination C. Yes? So you should call this recursive function in that way. Right? And then finally move which disc from where to where? In general. Move which disc from where to where now? Move which disc from where to where, students?
N to N from
N
source
from
to
A
destination.
to source to destination. Then finally, whatever is n minus 1 disc on B, which is on the auxiliary peg, I should move it to where? Should move it to where, students? This n minus 1 disc which is on B, I should move finally to where?
Destination, ma'am.
Destination C using which peg? Using A. So that's what the general recursive tells. Okay. Now, is the screen, 1 second. Okay. Is the screen visible of the video, students? Yes or no? Yes or no? Is it visible?
Yes, ma'am.
Okay, 1 second. Okay. Is it visible? Is it visible? Is the screen visible?
Yes, ma'am.
Okay. Fine. So the Tower of Hanoi, it's a very famous game. Usually the kids do play it. Okay. And you all know that in this game, we have 3 pegs, which we always call as towers or pillars, but usually in most of the textbooks they refer it as pegs. 3 pegs and n number of discs placed one over the other in what size, students? In decreasing size. So when I tell decreasing size, whether it is from top to bottom or bottom to top.
Bottom to top.
Top, yes, so decreasing size. And you all know that the objective of this game or the puzzle is to move the disc one by one from the first peg to the last peg. So which we call it as source peg to the destination peg, right? And we also know that there are some conditions. So the condition is we can move only one disc at a time, and we cannot place a bigger disc on top of what, students? On top of the
Smaller disk.
smaller disk. And there is only one auxiliary peg available to do the movements. That's the reason. See, if there are many auxiliary pegs, I could have placed all the disc in all the auxiliary pegs and easily moved it. The task is not difficult in that case. But here you should have only one auxiliary peg available for the transferring of disc. Okay. Example, the same example which we have taken here. So you can see here, the pegs will be labeled as ABC. Remember, A is the source, B is the auxiliary, C is my temporary, destination peg. So we have 3 discs taken, decreasing in the size on the direction bottom to top, right? Yes or no, students? Right? So the objective for us here is to move the disc from which peg to which peg? Which peg to which peg, students? Which peg?
Source to destination.
Oh, what is the peg named here? Peg is named as what, ma?
A to C.
A to C, in such a way that they are in the same order. That means to say that I should place it red, the first, then green, and then blue from top to bottom as they are in peg A. So that should not change. Okay. Isn't it so? Yes or no? So no, students. How to now solve this way? So it is recursively we are solving it. So we will use a general notation here. So T is the name of the function where N is what, students? What is N for me? N is what here? N denotes what? Number of
Pegs.
Number of
Number of discs.
Number of discs. See, number of discs can vary, but pegs are how many? How many pegs are available for me?
3.
3.
Disc can vary. Disc can be 1, 2, 3, 4, but pegs we have only 3 pegs: source, auxiliary, and the destination. Very simple as it is. Okay, so I use the notation beg here to indicate my source peg, aux to indicate my auxiliary peg, and n to indicate my final peg. Is that clear? Okay, so you all know that first you should move what peg, students? First you should move what peg? How many pegs should you move first? First you should move how many pegs? How many pegs? Yeah.
1.
So sorry, how many discs? Sorry. How many discs should you move?
N minus 1.
N minus 1. From where? From where?
Beginning to end using auxiliary.
From where? From where?
Beginning to end.
Beginning, I should move to where? See, just remember the notations here. In the function, in the recursive function, first is my source peg. Okay, beg is the source peg, aux is my auxiliary peg, and this is my destination peg. So when you are transferring also, you should assume the same order. You are transferring from beg to end using auxiliary. Right? This tells you that you are transferring from beg to end using, in between I wrote auxiliary. This is my final goal. I should transfer all the ends from beg to end using auxiliary. Similarly, now tell me, I should transfer how many disks next? I should transfer how many disks? First step. How many disks should I transfer, students? How many disks? N minus
N minus 1.
1 disk. From where? From where?
Beginning to auxiliary.
Beginning to auxiliary. See, look at this. First I have written beginning. Get it? And then at the end I have written aux. Okay? And in between, using what? Using which peg?
End.
End peg. That is the final peg. So when you are writing the recursive function, you should write it in this way. The first peg, this is the source peg. Last one is the destination peg with respect to the operation. So you should remember that I am moving n minus 1 disk from the source to auxiliary using end. Remember, from beg to auxiliary using end. So you should tell me when I write the code correctly. Next, what should I move? What should I move next? Which disk should I move? Which disk should I move next after this? The nth disk, which is available. It is 1 here, but actually it is nth disk. So I should move the nth disk from where to where? It is a one movement. From where to where should I move? Nth disk. From where to where, students?
Beginning to end.
Beginning to end. Okay. Then the last step here is, what should I write last now? Last one. I should next move n minus 1 disk is now present on which peg?
Auxiliary.
Auxiliary. So tell me the function call here. T of, what should I write? T of
N minus 1.
n minus 1, comma, where is it present?
Auxiliary.
Auxiliary, comma, next
Beginning.
beginning, comma,
End.
end. The reason I should write that is very simple. My n minus 1 disk, sorry. Okay. 1 second. Okay. So you can now observe that here. My n minus, is the screen visible, students?
Yes, ma'am.
Yes. So I have to move n minus 1 disk, which is on my auxiliary, to end using the source peg, that is beg. You understanding? So if you remember this, if you have understood how the problem is being solved, it's very simple. But when you write the parameters, you should remember n minus 1 disk, which is on the source, that is beg, should be moved to auxiliary using end. Then here, n minus 1 disk, which is on the auxiliary, move back to end using beg. Very simple as it is there. Right? Now, so as it has been shown here, you can see, move top n minus 1 disk. See, that's the reason I'm giving you a top. You cannot move any disk. It is top n minus 1 disk from beg to aux. Beg to aux using end. Okay. Step 2 tells move the 1 disk which is available from beg to end. Isn't it? And what is step 3 telling you, students? What does step 3 tell? Can anybody tell? Step 3 says what? Move. Move.
N minus disk from auxiliary to end.
Auxiliary to where?
End.
End using beg, right?
Beg.
So move top n minus 1 disk again, which is there from aux to the end peg, right? Okay, so you can just see this portion, right? Hope it is visible, students. Is it visible?
Yes, ma'am.
Yes. So you can see we have now number of disks is 3. So what is the initial call? Initial call is what for me? T. How many disks I have? How many disks I have, students? Speak out.
3.
3. And they are placed in which disk? Oh, sorry, in which peg?
A.
A. From A, I should move to where?
C.
Using what?
B.
B.
Yes, right? This is your initial function call, right? Remember. Right? So just see, just look at this, how the flow goes. Okay, these are the steps now. Fine. So we will just apply this on this. Tell me, what is the first step in this case? What is the first step in this case? Students. First step. T of what should I write? T of
2.
2, comma. What should I write?
A.
A, comma.
C.
C, comma.
B.
B. Okay. Let us see whether he writes, we have the same. T of n is equal to 3, beg is A, aux is B, and end is C for me here. Right? So, the step 1, we will get to A, comma, C, comma, B. So, what does it mean? Move top 2 disks from A to B using C. Getting? So, you should remember the towers, how we are writing it. Okay. Okay, so this means to say that I am moving from, one second, I am moving from which tower to which tower? Which tower to which tower, students?
Source tower to auxiliary tower.
Auxiliary tower using the destination tower, right? Okay, just look at that. So T to A comma C comma B. Okay, you have still 2 disks, so you cannot move it so easily. Next, the second step is what? Moving the only disk which is on A to C. So you will move the disk from where to where, students? A to C. Very simple there. Okay, and what is the third step that we have now? T of 2, my aux peg is now B to C using A. Isn't it? So on B there are 2 pegs, 2 disks. I should move it to C using A. Okay. Just look at this now, how it moves. Just look into it, how it is moving. Okay, so can you just now tell me now what's happening here? So you can see when you have 2 disks on which tower there are 2 disks for me in this case. On which tower we have 2 disks, students? In this case, on which tower you have 2 disks? On which tower you have two discs, yeah? Tell me. Right now, the two discs are on which tower or on A?
Source tower.
No. In this case, see, in this case, the two discs are on which tower? A or B or C?
B.
B.
They are on B. From B, isn't it? No. Right now, this function does what for me?
On
Move,
A, ma'am.
it moves the disk from A to B using C, isn't it? A to B, it should move from A to B using C. So how does it move? Just see, how does it move now? The first move will be from A to C. It will move one disk from A to C. Can you observe this? A to C. So which is that A to C movement? The first disk number 1 will be moved from A to C. Next, what does it do? It moves from which disk to which peg to which peg here? Students? Which peg to which peg? Which peg to which peg it moves?
A to B.
A to B. Just observe this. Very simple. You can just tell me how it moves A to B. That's all. Right? The movement is from A to B. Only one disk, which is the disk, the topmost disk, which is on A, it will move. So can anybody tell me the disk number in this case? Disk number. Disk number. What is moved from A to C? Which disk number? So you know the disk numbers are named as what? 1, 2, 3, right? Right? So which disk is moved from A to C now?
First.
The disk number 1. Okay, disk number 1 is moved now. In this case, which disk is moved? From A to B. Disk 2. And in this case, whatever is, the movement is from C to B. So which disk will be moved?
1.
1. So, would you observe now, this function moved me two disks, right? Which was on A to B using C. Okay. Next is move from A to C. Which disk is moved, ma? Disk number. What is there on A now? Which disk? Disk number?
3.
3.
3. So 3 will be moved. Very simple there. Okay, next is moving the two disks which are there from which pillar, which peg? Which is on which peg?
Auxiliary peg.
Auxiliary to the destination using my source peg. Okay, so let us see how it moves. Just look into it. So in this case, my beginning is B because I'm moving. That is my source peg in this moment of time. Okay. So you are moving from B to A. Okay. Okay. Can anybody tell me now which is moved in this case? Which is moved?
First peg.
Okay. First peg is moved from B to A. Very good. First peg. What? Yeah, you people are very good telling peg. Disk, yeah. Disk, right? Okay. Next. Next, what is moved? Tell me what is moved now in this case. What is moved?
Second disk is moved from
Yes,
B to
second
C.
disk is moved from B to C. Very good. So this is moving, I think, disk number 1, right? Yes, 1 to B to A, then B to C. Then at the last, students, last one moves from which pillar to which?
A to C.
A to C. Very good. To C. Okay, very simple there. So here we are moving disk 1, here we are moving disk 2, and finally we are moving disk 1. So that means I am moving the two disks which are on B to C using A. Correct? Yes? Yes?
Yes, ma'am.
Yes. Okay. So I have a question for you all. How many moves we add here for 3 discs? How many moves?
7, ma'am.
7. Okay, very good. So we had 7 moves, okay, for 3 discs. So if I have 3 discs, so 7 moves. So if I had 2 discs, sorry, how many moves? How many moves for 2 discs?
3 moves.
3.
3 moves, very good. So for 1 disc,
1.
so now, in general, if I have n disk, then how
2n minus 1.
2 to the power n minus 1. This is commonly asked Viva questions in your exams. So if you have n disk, the number of moves will be 2 to the power n minus 1. Ma'am, you might tell me, ma'am, this is 7 is, say for example, 3 into 2 plus 1. 3 into 2 is what? 6. 6 plus 1 is 7, ma'am. Okay. Probably that is true when it is number of disks is 3. But when number of disks is 4, it is not the right one. So if you have 4 disks, you should make how many moves? How many moves? You should make 15 moves. You should make 15 moves. You can check out, right? That will be your assignment for the next class. So 15 movements will be made in order to perform the Tower of Hanoi problem and number of disks is 4. So in general, this is the formula. Yes? Okay, I'll just play the video again here. Just look into it. So whatever moves we just saw there, so it is put here. That's all. Okay, see now. Are you able to see? Are you able to see, students?
Yes, ma'am.
A to C. So let me stop at this point. See, A to C means move only one disk from A to C. That's what it means. Okay, just check. Next, what should it move? Which disk it should move? Which color disk it has to move next? Students. Am I audible?
Yes, ma'am.
Okay. So which color disk it will move now? Tell me which will move. I should only tell, yeah. People don't want to tell. Okay. Last one you tell me. Which will be moved from where to where?
A to C.
A to C. So it will move from A to C, the red disk. And you can see at any point of time, we are moving only one disk and we are not placing a larger disk on a smaller disk. Isn't it? Totally 7 moves is required. So there is still research going on to reduce the number of moves, but that is not possible as of now. They have not found the solution there. Okay, see the algorithm is like this. If n equals to 1, just move from back to n, else do these things. Okay, that's what I have just told there. And if there are n disks, we can solve the game in minimum having how many moves in general? How many moves? How many moves? 2 power n minus 1 moves. Okay, so minimum Maximum you can take more, but minimum is this. Is that clear, students? Yes or no? Students. Students, is it clear?
Yes, ma'am.
Okay. Okay, now, so you should quickly tell me the design of the program. Okay. The program goes like this. So first I am writing the main function, then I will write the recursive function for you all. Okay. What is the input? What variables should I create? Students.
Disks.
Disk. So should I mention about the pegs or not required? How many pegs are there?
3.
3.
And it is not mandatory or not required only to mention the pegs. So I declare one variable n. So you might think, ma'am, how to show that picture and all? We are not showing any picture. We are just printing the movements of disk. Which disk is moved from where to where? That's all. Okay. So I'm printing the Tower of Hanoi. What is that? Documented statement. Okay. And then ask the user to enter what, students?
Number of disks.
Of disk. Okay. And then he will enter the number of disks. I'll store it at n. Next, I will call one function which performs the job of moving the disk recursively. So I have assumed that, can you all see, students? Okay. A is the source as usual, B is the auxiliary, and C is the destination. And the function name, I give it as tower. Now tell me, what is the initial function call here? Tower. What is the initial function call? Move from where to where? Students.
Move n minus disk from A to C.
Move n minus 1.
N,
N or n minus 1?
n minus 1.
Hey, initially, what is your target? What is your goal? Sorry.
Move n.
N. Move n from where to where? From where to where? A to C using B. So the function call will be like this. Students, just remember, tower n. So pegs, I just simply cannot write A, B, C. They should be represented as a character. Okay, A, B, C. So first, my goal is what, ma? Moving n disk from A to C using B. Understanding? Later, when I call this, then I will break n minus 1 disks and all. Okay, my initial thing is to transfer n disks from peg A to peg C. Yes or no, students? Yes. Now, I should now design the function definition for this. Oh my God, 1 second. Definition would look something like this for me. Okay. So I've just included the header file as of now, and the recursive function is like this. Just see what I'm just giving here. In the recursive function, n indicates the number of disks, T indicates, S indicates the source peg, T indicates the temporary peg, and D indicates what peg, students? What peg?
Destination.
Destination. You can give your own names. I have just given this name. It's left to your convenience. Okay, fine. Now, the function definition is like this: void tower int n is integer, and a, b, c, so which I have just named as std, they are all characters. Okay, so you all know that in the recursive case, there should be a base case, or we call it as a terminating case, which terminates your function at some point of time. So at some point of time when it wants to terminate, you should give the base case. Otherwise, the recursive goes on. So the base case is if the number of number of disks is equal to 0. When n is equal to 0, just return. Don't do anything. Okay, number of disks is 0. This is the base case. Remember. Okay, so at some point when number of disks becomes 0, just return. Okay. Next, if number of disks is not equal to 0, so you should break the problem into sub-problems. Can anybody guess what is the next function call? So there are now n disks. So if there are n disks, what should I do? What are the 3 steps? First, move what? Move what, students? Move how many disks? Speak out.
n-1.
n-1 disk from where to where? From
Starting to destination.
I should move from source, the n-1 disk which are on source, I should move to where? Move to where, students? It is on the source, the top n-1 disk, I should move from source to where?
Destination.
n-1 disk, yeah? You will move it to destination.
S to T using D.
You will have to move from S to T using D. So what should I write in the second list? I should write T or D?
D, ma'am.
D. So you remember that. See, in the function call, first one is the source peg, second one is the auxiliary peg, third one is the destination peg with respect to what you are doing. So you are moving n-1 disk, which is on the source, to temporary using D. So my function recursive call will be like this: tower of n-1 comma s comma d comma t. So I am moving n-1 disk from source, that is S, to temp, that is T, using destination. Yes. What is your second step? You moved n-1 disk. What is left now on source? What is left? Nth disk, isn't it? Yes or no?
Yes, ma'am.
Move nth disk from where to where? From source to
Destination.
destination. So I'll just print. I told you here we cannot simulate and show. So we are printing it. Let's just see, observe here. Move, printf, move percentage disk from percentage C to percentage C. So what is percentage D here? N. Nth disk is N. From where? From source to destination. Clear? Clear, students?
Yes, ma'am.
Okay, now tell me the last recursive function call. Someone can tell with your name. Last recursive call. Move n-1 disks which are placed on where?
Temporary peg.
Temporary to
Destination.
destination.
Using source.
Using. Tell me the function call. Your good name?
Girish, ma'am.
Okay, tell me the function call. What should I write?
Tower
Yes.
n-1.
Yes.
T,
T, okay.
comma S,
One second, let me write. So you are telling n minus 1, then T, comma,
S,
yes, very good,
comma D.
comma D. So you mean to say I'm moving n minus 1 disk from temporary to destination using source. Let me see. Yes, very good, Girish. Tower n minus 1 T from temporary to destination using using source. Yes, and that ends our function. So you can see very simple this is. You have to just understand. The rest all the system will do it on your own, do it on its own. Simply see iteratively if you would have written this, it would have taken long time. Simple thing, we will do it here. Understood, students? Did you all understand? Oh my God, did you all understand? Huh? Let me execute the same for you all. Did you all understand, students?
Yes, ma'am.
Okay, so I've written the same thing here. The only addition what I have just made is I have included how many moves are made. Okay, so let me explain that also with the output. First, see, let me give, let me start with 0. Okay, if there are 0 disks, will it perform any movements? Will it move any disk? Are there any moves?
No, ma'am.
So total number of moves is how much here, students? 0. There's nothing to do. The number of disks is 0 there. Okay. So a commonly asked question in your Viva, they will ask you, can I have more than 3 pegs? What will you answer?
Yes.
You can have more than 3 pegs. I'm not talking about the real peg, yeah. I'm talking about tower HANOI peg. Students.
No, ma'am.
Okay. How many pegs are available as per the problem?
3,
3,
ma'am.
ma'am.
3. One is source, one is destination, the other one is the temporary. So 3 pegs you cannot have in the problem. More than 3 pegs, it's not possible. It is not allowed. The problem statement is only like that. Try to understand. One is source, one is destination, and the other one is a temporary one. Very simple as it is. Okay. How many? There are number of disks is 1. How many movements?
1.
The movement is from where to where? Move.
Source to destination.
Okay. So numbering is disk 1. Can you see? Total number of moves is 1. Move 1 disk. I think I should have named it in the other way around. 1 second, students. I'll just change this. What should I write here? Move disk percentage D. I'll write here. Okay, that will be more clear. Isn't it? Yes or no? Students. Move which disk ma? Disk 1 from A to C, because A is my source, C is my destination. Isn't it? Okay. Number of disks is 2. How many moves?
3.
3. Okay. What are the 3 moves? Disk, move. What are the 3 moves? Can you name it? Someone can name it.
A to C, B to B, C to A,
Disk,
and
disk.
A to
1 second. First movement. Disk 1 from. Yes, tell me.
A to C.
Disk 1.
A to B.
A to B. Move disk 1 from A to B. Next. Disk 2 from?
A
A
to
to
C.
C.
Yes. Next. Disk 1 from?
B to C.
This one from A to B, this two from A to C, this one from again back to B to C. Yes, 3 moves. The next number of disc is 3. How many moves? Yeah,
7.
7.
7. So we have 7 moves and you can observe it. Disc 1 from A to C, disc 2 from A to B, disc 1 from C to B, disc 3 from A to C, disc 1 from B to A, disc 2 from B to C, disc 1 from A to C. Yes? Yes, students? Yes or no?
Ma'am.
Yes, is the formula matching? Yes, you can see there are 7 moves and here 7. Similarly, we have also for 4 discs, you can see 15 moves, you can see here 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 moves. You can see this. Yes or no? Students?
Yes, ma'am.
Yes, I think as the number of discs increases, obviously the number of moves will also increase. So, as I told in the beginning in the video, there is a city called as Hanoi in Vietnam, wherein there are monks sitting there. Okay, what we call monks is they're like sannyasis, right? Sitting there, and there are around 100 plus discs placed on the source spec. That's one of the what do you tell? A belief. Okay, so the moment they finish completing moving those discs from source to destination, the world will come to an end. So as the video said, the world has come to an end at many times, right? That's how it is. So just to count, I mean to put the number of moves, I have included math.h and calculated the total number of moves as power 2 comma n minus 1. So power is a function which calculates 2 power n value. Okay, and this will give me a float value. So just to typecast to integer, I have put the typecasting here. That's all. Clear? Clear, students?
Yes, ma'am.
Okay, very good. So any queries you can ask me. You can ask me. Thank you. Any queries? Students? Any
No,
queries?
nothing.
Nothing to tell. Then I can pose some questions for you all. Yes or no?
Yes, ma'am.
Yes. Okay. In Tower of Hanoi problem, how many pegs we have?
3.
3.
3 pegs. So can you name them?
Source, auxiliary.
Source,
Source,
destiny, and
auxiliary,
auxiliary.
destination.
Um, what is the motto of Tower? Someone can answer. Motto of Tower of Hanoi problem. Tejashwini? 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 Am I audible? Am I audible, students?
Yes, ma'am.
Yes, tell me what is the problem goal of Hanoi?
Smaller disk cannot be placed on the bigger disk.
Not the conditions. What is the problem statement? Problem statement.
Tower of Hanoi with 3 pegs.
Yes,
Uh,
where there are end discs on.
and there are n disk on 3 pegs. Source, destination, and auxiliary.
Okay. So what should I do with those discs which is on the source peg?
Uh,
Where should I move it?
From source to auxiliary.
Very good. Okay. How many recursive? Okay. What are the conditions in tower of Hanoi problem?
The smaller. Hello.
Yes, tell me, Tejaswini.
The smaller disk cannot be placed on the bigger disk.
Yes, very good. Tell me the next condition.
And we can move the disk. Only one disk can move at a time.
Very good. Next.
Yeah.
Three conditions. No, which is the other condition?
Only
How many auxiliary pegs are available?
3 pegs are available, ma'am.
Auxiliary peg.
One.
Only one is available.
Yes.
Yes. Okay. Can I solve the tower of Hanoi problem using iterative? Tejaswini, let someone answer. It's okay. Thank you, Tejaswini. Good. Can anybody answer to the question? Can I solve tower of Hanoi problem iteratively? Yes or no?
Yes, ma'am.
Yes. Which is better, iterative or recursive?
Yes, sir.
Which one is better?
Recursive.
Recursive. Iterative also you can solve, students, but it becomes slightly complex, complicated, a tedious way of writing large amount of code. Right? Simply you can go for recursive. Okay. What is the recursive solution? One person can just tell in statements. First step. Quickly. Mohan. GT Mohan.
First one,
Yes, tell me the steps in the recursive solution.
n minus 1 should be moved from A to C using B.
Move n minus 1 from A to C using B. Then your problem is gone. First step only you're out, Mohan.
I'm A to B using C.
Oh, A to B using C. Okay, correct. Next step. Next step, Mohan. You are there. Students. Okay, Mohan is not there. Next step, second step. First step is move n minus 1 disk from A to B using C. Second step.
I'm N from my A to C using B.
Nth disk from A to C. That's it. Using B not required. One disk, no, I will just move from A to C. Last step. Someone can tell me the last step?
Move n
B to
minus
C
1
using
from
A.
B to A.
Okay. Tejaswini, just tell me.
Move n minus 1 from B to C using A.
Okay, B to C using A. Very good. Okay. How many moves in general if there are n disks?
2n minus 1.
2 to the power
N minus 1.
N
n minus 1. Okay. I hope concepts are clear. So, as usual, tomorrow or day after tomorrow, a small quiz will be scheduled based on the program what we had done today. And similarly, you have to write the code in the observation book, execute it for 1 disk, 2 disk, 3 disk. Okay, and post to the assignment. And you have to write one more thing in your observation book. The steps involved in moving 3 disks. Right? You want me to show how it is, or you will try doing it? You want me to show how it is? Students? To 3. The steps, step by step, you will have to just write it. So I'll just show you one thing for 2 disks. Like that, you will have to just write in your observation book for 3 disks. Okay, see here. First write the 2 disks on the peg A and B, which is empty, and C also, which is empty. So name this as 1, name this as 2. Okay, what is the first movement here? Move disk. What is disk? 1. From where, yeah, students?
A to B.
From A to B. Okay, so move disk 1. So next step, you should again rewrite this. Okay, this is disk 2. This is the peg B. This is peg A. So on B, there is disk 1 and C remains empty there. Okay, similarly here, in the next, you should write the statements. I am not writing here, you have to write the statements. Next statement is what? Move. Move what? Students, speak out. Move. What's the next statement? Are you all there? Move what?
2 from A to C.
This 2 from A to C. Okay, like this. So differing in the size, you can use color pencils. Okay, like this, you should write the steps. So totally, you should have 2 to the power 2, 3 moves, right? So the last one is here, the B, then C, 2 here, moving 1 to B to C. Like this, you can make it innovative as possible for 3 disks. I want you to write for 3 disks. Will you all do it, students? Yes?
Yes.
Okay. So you can just post that in the assignment. Saturday or Monday, you should have to give the quiz. Anyways, I'll post it in the WhatsApp. You can be prepared for it. Any doubts, you can ask me. Otherwise, you can end the meeting.
Ma'am,
Mama.
lab manual, will you send the soft copy, ma'am?
Lab manual.